Hi everybody, this video is going to be an example about how to use Excel to calculate the binomial probability formula. So the question that's on your screen is the perfect kind of question that you can answer using the binomial probability formula. The question says you're taking a multiple choice test. It has 10 questions and each question has 5 choices. You have no idea about the content at all, so you have to guess every question. What is the probability that you will get exactly 6 questions correct? So that's the kind of question that you can answer with this formula. Now I know you already know the probability of getting 1 question correct. That would be 1 out of 5 or 0.2. But we're looking at what's the probability that you'd get 6 out of 10 just from guessing. So on the screen now is the formula. The binomial probability formula requires that you know 3 values. You need to know the number of trials, and in this case, the number of trials is going to be the number of questions on the test, or 10. You need to know the probability of success on each trial, and we already talked about what that was. It's 1 out of 5 or 0.2. This slide shows Q as a separate number, but Q is the probability of failure on any trial. That number is always going to be 1 minus P, or in this case, it's going to be 4 out of 5 or 80%. And the last number you need for the binomial probability formula is the number of successes that you're looking for out of the n trials. So in this case, we're wondering what's the probability that we'll get 6 right. So now if you look at the formula, you'll notice that it starts with our handy-dandy formula for the number of combinations. In this case, if we do the number of combinations of 6, n given 6, we're basically asking what are the number of ways that you can get 6 questions right. Can you get out of 10, right? Can you get the first 6 questions right? Can you get the last 6 questions right? Can you get the first 3 and the last 3? And so on. So that's what this part of the formula is. And then we're going to multiply the 2 probabilities, the success probability raised to the power of the number of successes. So this will be 0.2 raised to the 6. And then we're going to raise the probability of failure, which is 0.8, to the number of failures. In this case, the number of failures is n minus 6, x, which is 10 minus 6, or 4. So this will be the combinations times 0.2 raised to the 6 times 0.8 raised to the 4. So let's go to Excel and actually calculate the formula. So first thing I'm going to do is I'm going to type in my 3 variables. I'm going to label them so I remember what they are. So my variable is x, the number of successes I'm looking for. N is the number of trials. And P is going to be the probability of success on any one trial. So now you remember our formula had 3 parts. We did the number of combinations, the number of ways you can get 6 out of 10 right. And the good news is in Excel, we don't have to do all that factorial stuff because there's a stored function. If you type the equal sign and then you start typing the name of the function, it comes right up for you. It's combination, the number of combinations. So, oops, typo. So let's go back there, try that again. Open parentheses, the number of questions is 10, followed by the number that we're looking for, which is 6. And this is going to tell us that there's 210 ways of getting 6 out of 10 questions right. The second part of our formula was P raised to the p raised to the, come on, one more time, p raised to the x power. So that was my label. Now I'm going to actually use, rather than retyping the numbers, I'm going to grab the formulas p raised to the x. And what's good about this is we can use this later if we want to change some of the numbers. We don't have to retype the formula over and over. And the last part was the number of failures, which is 1 minus p, raised to the number of number of failures power, which is going to be n minus x. Okay, so to type that in, I'm going to go to the cell where I want it. I'm going to type plus open parentheses 1 minus, I'm going to click on the p. I'm going to close parentheses, and then I'm going to raise it to the open parentheses n minus x. So here are the three parts of the binomial probability formula, and I'm going to multiply them together here. And I'll have, this will tell me the probability of getting 6 questions out of 10 on the multiple choice test, where there's 5 choices for each question, and I don't know anything about the content. It shows, I clicked on the percentage so it would be an easier to read number. It shows that our probability is 1%. It was actually less than 1%, pretty low. This is kind of nice because, you know, I can just, because I've set it up in Excel, and I can easily change my x. If I change it to a 7, it tells me I have a 0% chance of getting exactly 7 right. What if I put a lower number like 3? Oh, I have a 20% chance of getting exactly 3 right. What if I put 0? Ooh, 11% chance of getting none of them right. So here we have the binomial probability formula in Excel. But I don't really find this that useful looking at these numbers in a vacuum. I much prefer looking at the binomial probability distribution. In other words, it's kind of cool to look at all of the numbers together rather than sitting here and changing x from 0 to 1 to 2. It's nice to look at them together. I think it helps us see really what we're doing here. So I'm going to change this spreadsheet slightly. I'm going to change it so that it shows all 11 results, really, right? There's 11 choices. You could get none right, or you could get all 10 right. So that's a total of 11. So rather than having just one x value, let's create a table of x values. I'm going to create a table of x values right here. Type a capital X, and then I'm going to make this a 0. I'm going to drag this one over here just to make my life a little easier, and then I'm going to type all the numbers up to 10, 5, 6, 7, 8, 9, and 10. If I move these formulas over here, let me see what happens. Just moving them over here, because now instead of looking at it for one, we're going to look at it for a whole table, but we've just got one row filled in. Let me move my titles here so we know what we're looking at. This is our number of combinations. There's 0 ways to get, there's 1 way to get 0 right. That's what that's telling you. Okay, oops. I'm just dragging these things over here. Okay, now I want to look at these formulas, and I want to change the cell references from relative to absolute. And I'm going to do that by clicking 4. Put my cursor over each cell reference and click F4. tells Excel that I always want it to pull those numbers, even if I copy the formula. Actually, I shouldn't have done it for I3. I really should have only done it for n, because n is never going to change, but the number of successes is going to change. Okay, now I'm going to go to this formula and do the same thing. I want to keep the number of probabilities is always going to be G4, so I'm going to click on that and put an F4 on that. Now go to this formula. Okay, the I3 should be relative, but the G3 and the G4 should be absolute. So I'm going to click F4, F4. And then this last one should just be the multiplication. Yep, so that looks good. So if I copy these, this shows you, this is just the computations inside, but right here, this column N shows you the distribution of the probabilities. It shows you that you have an 11% chance of getting none, a 27% of chance of getting one, a 30% chance of getting two, and so on. If you sum this column, you should find, I hope, that you have exactly 100%, because doesn't that make sense in our probability world that, you know, you have a 100% probability of getting 0 to 10 questions right. So that's the sum. We could also, with this format, we could also answer questions, which I think I saw one on your homework like this, where they said, what's the probability of getting 8 or more right? In that case, well, let's do 7 or more. In that case, we would want to say, we would want to sum these probabilities here. You'd either get 7, 8, 9, or 10 right. The probability of getting 7 or more right, ooh, still pretty low. Ooh. Oh well, so you better study for those tests. That's what this lesson is. I hope this was helpful.